Okay, so a circle is a set of all points that in a plane that are a distance r from a given point, which is your center. So all points on the circle are the same distance from a given point called the center. Now, I wrote here the distance formula. This is the distance between 2 points, x1 comma y1 and x2 comma y2. It's really, if you want to think about it, basically like Pythagorean theorem. Okay, so if I was just kind of jotting down on this, let's say I have one point that is x1, y1, and I have a second point, which is x2, y2, and I want to find the distance between those 2 points. What we really do normally is we make a right triangle, we figure out this distance here, which is really basically us subtracting these 2 coordinates is going to give me this distance. This distance, so when I say subtracting, the y1 and the y2 is what I'm subtracting to get this. This distance, I'm taking my x1 and x2 and subtracting that. And then by Pythagorean, I would take this, which again would be, if I jotted this down, for example, y2 minus y1 would be that side, x2 minus x1 would be that side. This side here is the distance I'm looking for. That is my hypotenuse. So by Pythagorean, I can take this quantity squared plus this quantity squared equals distance squared. That's where this formula is coming from. So if I was thinking about d squared is equal to x2 minus x1 squared plus y2 minus y1 squared, that is from my Pythagorean theorem. Then I don't want d squared, I want d, so I take the square root. And that's how I got this equation. So the distance formula really is just Pythagorean, okay? And again, what are we doing? We are just subtracting our x values and then squaring that quantity, subtracting our y values and squaring it, and that's how we get this distance formula. So how does this relate to a circle? Well, if we know a circle is the same distance from a given point, and that point we're going to call h comma k. Okay, we're going to call that h comma k. It is our h comma k. And that distance that it's going to be, what do I want to do highlight? That distance that it's going to be over and over again is going to be my radius r. And so for any points on my circle, any point on my circle, it is r away from that center. And so the point I'm going to call it is just an x comma y. So then if I'm using these 2 points, my x comma y, my h comma k, to find the distance between them, and I know that distance is r, I put r here because I know the distance is r. I'm going to find the distance between these. So I'm going to take my x minus h, square it, my y minus k, square it, and take the square root for the radius. If I just want the r. Okay, that would be distance. Well, if I square this side and I square this side, so I square this side and I square this side, I end up with x minus h squared plus y minus k squared equals r squared. That is how we get a circle. It's really from the definition of a circle being the same distance every point from a given point called the center and the distance formula. Okay, that's how it is derived. So now what we're going to be doing on those next sheets that I gave us, we're going to be trying to find an equation of a parabola from its definition. So again, the definition of a circle is the set of all points in a plane that are a distance, the same distance, and that distance is r, which is your radius from a given point, which is your center. Okay, so for the parabola, definition of a parabola. A parabola is a set of all points P such that P, that point, is the same distance to a fixed point called our focus and a fixed line called the directrix. So we have a fixed point called a focus and we have a fixed line called the directrix. So in this picture, here is our focus. Here is our directrix. And you'll notice that here's our parabola and they put a point P right here. And this point P is D away from the focus. And this point P in a perpendicular manner straight down is D away from our directrix. And that is how we get parabolas. So here, if we're looking at this, you see a focus. You see this line from your focus to a point on your parabola. The distance from here to here needs to be the same as the distance down to this line, which is called the directrix. And as I'm moving, you see that the distance from any point on my parabola to the focus, which is this distance here, is going to be the same as this distance here. Okay, that's by definition how these points get formed. Now, what you'll notice is as I'm bringing this point here to here, you see my focus and my directrix. Halfway between my focus and my directrix is my vertex. That's going to be important to us. That's going to be important to us. So on here, what's going to happen is we are going to be trying to plot a parabola, only knowing its focus and the directrix. This is special paper. This paper has these horizontal lines here. That's kind of counting on your Y. So this is 0, 0. This would be going 1 above, 2 above, 3 above, 4 above. Now, as I go out, this is 1 over, 2 over, 3 over, 4 over. But sometimes we need a diagonal distance. That's going to come from the circle. So, for example, anywhere on this circle right here, as I'm going and drawing this circle, every point I drew is 1 away from the 0, 0. Every point. So I could say, okay, I need this point here. Well, that's 1 away. I can measure that 1 away as a diagonal using the circle. So this graph has circles, and that distance, which is 1 circle out or 1 radius of a circle out, is the same as my 1 going here and my 1 going here, because it's the radius. So that's kind of why we have this paper. So what we're going to do is you're going to graph at 0, 0, a point. We're going to call it the focus. So I'm going to come to 0, 0, and I'm going to put a point, and I'm going to call it F, so that I know it's my focus and not my directrix. Okay, so I'm going to put F for focus. Okay, so put that on your paper. Then I'm going to graph the line Y equal 3. So in this case, in here, I'm going to move this F. I'm going to label it here. Okay, and I'm going to graph Y equal 3. That is going to be my directrix. So I'm going to come to 3. So I'm going to go up 1, 2, 3, and here I'm going to be drawing my directrix. So right here on this line, that is going to be my directrix, and that directrix is Y equal 3. And again, this is my directrix. Now we want to graph a parabola just from these 2 bits of information. Well, what I know is that the distance between my focus and my any point on the parabola and my directrix and any point on the parabola has to be the same. So if I'm looking at my focus here at 0, 0, my directrix here at y equals 3, can anyone tell me the coordinates of my vertex? So just trying to get a color we can see. So my vertex has to be halfway in between these. So if this distance is 3, it needs to be half of that distance, which is going to be 1.5. So it is here at 0, 1.5. Okay, that is my vertex. I'm going to put a V for vertex. Okay, so that is my vertex. Now, I'm going to continue graphing other points that are the same distance to that orange directrix and also to my focus. So since I had this one at 1.5, I'm going to go out to circle 2, okay? So if I go out 1, 2, anywhere on this circle, every point on this circle is going to be 2 away from my focus, but I also need a one that's going to be 2 away from this line here. So you'll notice, I'm going to do this in 2 colors here for a second. So this is circle 2, which every point there is 2 away from my pink focus. This right here in purple is going to be 2 away from my directrix. Do we agree? 2 away. I want it to be both on the circle 2 away, but also up and down 2 away. So you'll see that that's going to be here and here. Because again, I'm going out 1, 2 radii for my radius, but I'm also going 1, 2. So it's the same distance to here as it is to here. So again, I went out 2 for my circle, but I need to be 2 away from here. So 1, 2. And same on the other side. Let me get rid of that line and this for a second. So again, if I'm doing this, I'm coming out 1, 2. So I want this circle, but I want to be to this direction. Okay, so here to here, that's going to be 2. So on circle 2, I want to go on my circle until I'm 2 from here. Now, from here, how would I graph another point? I'm going to go out 1. So now I'm at circle 3. Right now at this height, I'm 2 away from my orange line. I want to be 3 away. So I'm going to follow the circle to the next line. So now you see I'm 3 away and 1, 2, 3 away. So now I'm going to go out 4. I'm going to go out to the next circle. Well, I'm 4 this way, but I'm not 4 this way. So I need to follow that 4th circle until I get to the next line below. And I'm going to keep doing that, going out 1 circle, down 1 horizontal line, out 1 circle, follow it to down 1 horizontal line. And we just keep on going out, follow it down, out, follow it down. And you can kind of see a pattern here, so I can kind of see where I'm going. And then I'm going to continue doing this. And let me do it on the other side. Okay, so again, I went out to my circle 2, and then I need to be 2 away from my directrix. From here, I'm going to go out to circle 3, but I need to be 3 away. So I go down 1, out to circle 4, down 1, out and then down one, and I keep doing that and doing that and doing that. Now, if I was to connect these with a curve, if I was to connect this with a curve, I'm going to do it kind of a little fainter so we can see through it. You see, there's my parabola. You can see the shape of my parabola from that. So my focus is at 0, 0. So I'm going to plot my focus at 0, 0. And I'm going to put an F there. I'm going to put the F above this. Actually, I'm going to put it below it. And then we're going to graph the line y equals 6. Okay, so I'm going to graph the line y equals 6. That is my directrix. And again, I'm putting F for focus. So if I'm trying to find points that are the same distance to this green line as they are to this red point, halfway in between this, which is 6 units, I'm going to go 1, 2, 3. So I'm really at 0, 3. Okay, I'm at 0, 3 because it's 3 to here and 3 to here. Then what I'm going to do is I am going to go out to, so right now I'm on circle 2. Okay, I'm circle 1, 2, 3. I'm out on circle 3. So I'm going to go out to the next circle, which is going to be circle 4. I'm just going to put a dot for a second. Okay, this is not where I want to be. I was putting a dot just as a reference. So right now, I am 1, 2, 3, 4 circles away. Right now, vertically, I'm 1, 2, 3 away. I need to be 4 away. So on this circle, I'm going to go to the next line, but I want to do it on the circle. And this is where I'm going to be right there. That's where I am. The reason I'm going to be 4 away is because, again, if I'm going from here to here, let me do it in not such a fat. If I'm going from here to here, I'm crossing 1, 2, 3, 4 circles. That's each one of those is a radius of 1. It's like one unit. And then going straight here, 1, 2, 3, 4. So here I'm talking 1, 2, 3, 4, like in terms of the horizontal lines, but vertically is what I'm looking at. And then here, 1, 2, 3, 4, going this way. Okay. So to get that point, again, to get that point, I come here, okay, to the one that's halfway in between. I'm going to go out to the next circle, but I need to go down on that circle to the next height. Does that make sense? And I'm going to go out and then down to the next height, out and down to the next height, out and down to the next height. I'm using kind of big dots, but I want you guys to see it. Out and then down to the next height on that one, and keep on graphing them. I'll do smaller ones for the next one. And then I'm going to do the same on the other side. So I come here and I'm going to go out to the next circle, but down to the next line. Out to the next circle, but follow it down to the next line. Keep doing out and then down to the next line. Out, and then I follow that circle down to the next line. And I keep doing that. And you see, I'm getting this parabola shape. There's my parabola. And let me just connect it. And you can see the curve of it. Now, in this case and the one on the other side, I'm just going to turn it for a second. Over here, both of these, the directrix was above the focus. The next one, the directrix is going to be below. So let's see what happens on that one. So the next one, we're going to have a directrix, a focus at 0, 0 again. So focus 0, 0. Now this time my directrix is going to be below. So I'm going to put my F here. And my directrix is going to be y equal -2. So y equal -2. So I'm going to come down here. And again, that's my directrix. Okay. And then what I'm going to do is to plot my parabola again, I need to be the same distance between both of these. So if this is at 0, 0, and this is down at 0, 2, -2, my vertex is going to be right here, halfway between. Let me get it. Now I need a little bigger dot. So it's going to be halfway, which is going to be right here. Okay, halfway between those. Pretend I could actually put it in the right spot. And when I'm doing this, and I'll make it a little bigger for us so you guys can see it. So when I'm doing this, I'm going to go out to the next circle, which I'm really 1, 2 circles away at this point. But right now I'm only 1 above. So as I went out 1 circle, I need to go up this time. Out 1 circle, up on that circle. Out 1 circle, up on that circle. Okay. Again, out to the next circle, up to the next line. Out to the next circle, follow that circle, up to the next line. And I keep going. Okay. And I'm going to do the same on the other side. And out to the next circle, up to the next line. Out to the next circle, up to the next line. And I'm going to do the same on the other side. Out, up, out, follow it, up, out, follow it, up. Now, this one that my directrix was below my focus, you see this one's opening up. The other ones where my directrix was above my focus, they were opening down. And there's my parabola. Okay, we graphed it without an equation. We had 1 point, which was our focus. We had 1 line called our directrix, and we graphed our parabola from it. If you know your focus and your directrix, you can write the equation of your parabola, and that's what we're going to be learning today. Okay. Write down. Okay, a couple things I want to write down. So again, you'll notice we had this one here, where the directrix was above, the focus was below, it opened down. Okay, this one was the same. This one, the focus and the directrix was below and it opened up. What I want you to notice is where the focus is. The focus is always in the parabola opens towards your focus. So it's opening up towards your focus here. It's opening down towards your focus here. So couple facts that are going to be important for us to know. One fact, the vertex is halfway between the focus and the directrix. That's always true. So your vertex is always halfway between your focus and your directrix. That's how I started this whole thing. Okay, so over here, the distance here was 6, halfway is 3. That's where my focus is. Another important bit of information that we need to understand is what I was saying a second ago. Your parabola opens towards focus. It always opens towards your focus. Always, 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 always. Those will both help us write the equation of our parabolas. Understanding that the vertex is always halfway between your focus and your directrix, and the parabola opens towards your focus. It's never going to go through your directrix. If you start drawing it towards your directrix, you're going the wrong direction. Now, something else just to kind of notice, do you see the distance from here to here? Okay, the distance from, well, I should say here, from my focus to my directrix, this distance here was 6, okay? In this one here, the distance from my focus to my directrix was 2. How does that distance affect your stretch? If your focus and your directrix are further away from each other, how does that affect the stretch of our graph? When my focus and my directrix are closer together, the parabola, the closer it is, the narrower the parabola is going to be. The further the focus and directrix are away from each other, the wider it's going to be. Okay. So we'll jot that down. I'm going to just jot it down here on the side of one of these. So the closer the focus and directrix are, the so here, this one, they were closer. This one, they were further. So the closer they are, the narrower the graph. Okay, the narrower the parabola. Okay. This is an example of that. I'm going to write it here, but I'm going to draw an arrow to the other one. The further the focus and directrix are, the wider the parabola. Okay, so the closer the focus and the directrix are, the narrower your parabola. Now I'm going to draw an arrow from this purple one up to the one above. The further the focus and the directrix are, the wider the parabola. I guess I don't really need those comments. So that is going up to this one here as an example. I just have a sketch here, not drawn to scale by any means. So we want to find the equation of a parabola with a focus at 0, c. So I'm not having my focus at 0, 0, it's at 0, c. So if this is 0, 0, this is up at 0, c. This is my focus. My directrix is at y equal negative c. Okay, my directrix is at y equal negative c. So this is my directrix, which is at y equal negative c. This is my focus, which is up at 0, c. Halfway between those is my vertex, which is 0, 0. Okay, so right here, my vertex is going to be 0, 0 because it's halfway between focus and directrix. Okay. Now we're going to use the definition to come up with our equation. So in this picture, we have this point, x comma y, we're calling it P, x comma y. We have this point down on my directrix, which is straight down perpendicular. So it's going to have the same x coordinate as the point up here. So that's why both of these have x as the x coordinate. But the y coordinate is going to be c because it's on this line y equals c, negative c. And then we have this point, which is our focus, which is 0, c. So by definition, the distance from P to D, okay, P being a point on my parabola, to my directrix, which is coming straight here to D, has to be the same distance as the same point is to the focus. And I wrote, again, the distance formula here for us so that we see the distance formula. If I have 2 points, x1, y1, x2, y2, I subtract my x's and square them. I subtract my y's and square them. And it doesn't matter really which one I do minus which one, because when I square it, whether it was positive or negative, it's going to become positive when I square. So by definition, I know that the distance from P to D, and when I write PD without a line segment drawn, I'm talking about the measure of that line segment. The measure, the length of PD has to be the same as the length of PF. So PD has to equal PF. That's by definition of a parabola. So now I am going to use the distance formula. So for PD, I'm using these 2 points, okay? PD. So I'm going to take the square root and I'm going to take the x's and subtract them. So this is going to be x minus x squared plus, I'm going to take my y's and I'm going to subtract them. Y minus a negative c. Well, y minus a negative becomes y plus c. So again, I'm taking y minus a negative c, which is the same as y plus c. I'm just using this formula. Equal, and I'm going to do the same for PF. So P to F, I'm going to take x minus 0, because those are my x coordinates, squared, plus, for my y's, I'm going to take y. This time it's going to be minus c squared. Okay, and again, I got it just by taking these coordinates, using the distance formula, taking these coordinates, using the distance formula. So now we're going to clean this up. So if I clean this up underneath this square root, this right here is going to become 0. 0 squared is 0 plus, and I'm just going to leave the y plus c squared right now. Okay, I'm going to leave it. Equal, and on the other side, I can clean up this x minus 0. X minus 0 is x, so I'm going to get x squared plus y minus C squared. Now, I really don't need that 0 here. I could really get rid of that 0 there. Does that make sense? I don't need it. So now what I'm going to do is I want to get rid of those square roots. So I'm going to square this side and I'm going to square this side. Now, when I square a square root, it undoes it. So when I square it, I'm going to be left with what's underneath my square root, which happens to be a y plus c squared. And some of us might say, well, why don't you just take the square root of this? Because if I take the square root of this, this is going to be just a y plus c. Yes, but over here, that's not going to be the case. I'd have to take the square root of that whole quantity. X squared plus y minus c squared. I can't take square roots of pieces of it. So I'm just going to get rid of the square roots. On the other side, when I get rid of the square root, I get an x squared plus y minus c squared. So now we want to multiply out y plus c squared. So y plus c squared is y squared plus 2cy or 2yc plus c squared equal x squared plus, and then this is going to be the same thing I got on the other side, but it's going to be a y squared minus 2cy still plus c squared. Okay, it looks like a mess, but I think I can clean this up a bit, because what you'll notice hopefully is that I have a y squared. Let me do it maybe a lighter color. I have a y squared here and a y squared here, so those are going to cancel out. I have a positive c squared here and a positive c squared here, so those will cancel out. What you want to be careful of is this plus 2cy and negative 2cy. Those are not going to cancel out because one's positive, one's negative. So what I'm going to be left with is 2cy is equal to x squared minus 2cy. Now, let's get our cy's together. So I'm going to add 2cy, so I get a 4cy is equal to x squared. So we're trying to get an equation for a parabola that has a focus at 0, c and a directrix at y equal negative c. Okay, that's what our goal is here. So now, since that's my goal, I'd rather have this be y equal than like this. So I'm going to divide both sides by 4c. And so this is really x squared over 4c, but I'm going to rewrite it like this. I'm going to write it as x squared. Let me start again. I'm going to write it as 1 over 4c times x squared. Okay. 1 over 4c is the same as me having the 4c on the bottom. Now, the reason I'm doing that is because this right here, what do I usually have in front of my x squared? Usually I have my a. So what does that mean? A is equal to 1 over 4c. This is something that we want to understand. Now, the question they asked us was to come up with the equation. That's the equation, y equal 1 over 4c x squared. But we discovered something important. We see that this a is equal to 1 over 4c. And if you're going, great, but I don't even understand what the c is. If I go back to the picture for a second, or write all over everything. If I go back to the picture, the distance from my vertex to my focus is c units, because my vertex was at 0, 0, and I went c above it. So what c is going to be for us, this c is equal to distance from vertex to focus. That's what it is. Okay, so next worksheet. Okay. Okay, we're going to write the equation of a parabola with focus at 3 comma -4 and directrix at y equal -2. So right now, what I want you to do is I want you guys to plot those. Plot the focus, plot your directrix, see if you can figure out what the vertex is. Okay, this is on your paper still. We're still on our paper. So I'm just going to plot my focus at 3 at 3 -4. And I'm going to label it with an F, so I remember it's my focus and not my vertex by mistake. And actually, I'm going to move that F because I need to draw in my directrix, and my directrix is going to be here at y equal -2. So I think I'm going to put my F here so it's not in the way. Okay, so I can draw my line. Now, we want to write the equation of the parabola that has this. We don't have that special paper to do this. Can someone tell me where my vertex has to be? So if I want to find my vertex is going to be right there, halfway in between. And they both are going to have the same x. They're going to both be 3 comma something. So this is going to be 3 comma 1, 2, 3. So this is going to be my vertex, and this is going to be 3 comma -3. That's my vertex here. I'll write it in black. 3 comma -3. That's my vertex. Now, if I know that that's my vertex, and I need to know what in the world direction this parabola is going, remember your focus, your parabola always opens towards your focus. So I know it's going to open this direction. And let me just put black here so we see that's that point. It has to always open towards your focus. So I know it's going to open down. Okay, I know it's going to open down. So that's just a sketch. So at this point, okay, knowing this information, I know that my parabola is going to be y equal a times, well, x minus h squared plus k is our general formula. So this is going to be y equal a. And since I just found my vertex to be at 3 comma -3, I know that this is going to be at x minus 3 squared minus 3. And now I need to find my a. Okay, so I can find my vertex easily by understanding where my focus and my directrix are, because they're halfway in between. But I need to find my a. And the one formula that I want you guys to remember is a is equal to 1/4c. Want us to know that. And c equals the distance from the vertex to your focus. So C is the distance from your vertex to your focus. So in this case, what is my C? Well, looking at my picture, here's my vertex, here's my focus. The distance from here to here is 1, but I'm going to say -1 because I'm going to also give direction to it. Okay, direction to it. So my C is -1. So what does that mean? Well, that means my A is going to be 1/4 times -1. So it's going to be a -1/4. Let me get that negative off my equal sign. It's going to be a -1/4. So now I know my equation. My equation is going to be y equal -1/4 times the quantity x minus 3 squared minus 3. That is our equation. And this is what we're trying to find. Okay, I'm using the graph as a tool, so I don't need to be accurate with it. if they don't give you graph paper, if this is on Cami, add a graph. We can always add a graph. Go to the Google Add Media and go to Google Search and add it. But you can also just sketch it up. Sketch it up. I personally like to see the graph sometimes. That way I don't have to visualize it in my head. I can just count. Okay. Let's do the focus. Okay. So I'm going to go to -1, 4. So 1, 2, 3, 4. That's going to be my focus. My Directrix is going to be below. So I'm going to put F here. That should be fine. So my Directrix is going to be y equal -2. So I'm going to draw this line in. And so I have y is equal to -2. Okay, so I've got my Directrix. I have my focus. And I need to now find my vertex. So when I'm doing this, halfway between my focus and my Directrix is my vertex. So I'm 1, 2, 3, 4, 5, 6. So I'm going to go 3 away. And my vertex is going to be right there. And remember, it's going to open towards your focus, not towards your Directrix. It's going to open towards your focus. I'm just going to make this a little fainter. It's going to open this direction, okay, towards my focus. So just from my focus and my Directrix and me sketching it, I can easily find my vertex. And I also will know what direction it should open, because it should open towards your focus. And let me just write the coordinates of this. This is -1, 1 is where that vertex is. So knowing that, I know I have y equal a times, because of the -1 for the x, this is going to be an x plus 1 squared, and then plus 1. To find my a, I need to use the information, the little formula, that a is equal to 1/4c. And I need to figure out what in the world my c is. So I'm going to figure out what my c is by looking here. The distance from here to here, the distance from here to here is my c. So how far am I moving here? Well, from here to here, my c is going to be 3, because I'm going 3 up to here. Okay. I'm going 1, 2, 3. From my vertex to my focus, my c is 3. So knowing that my c is 3, I know that my a is going to be 1/4 times 3, or 1/12. So my equation is going to be y equal 1/12 x plus 1 squared plus 1. That's my equation. So again, your c is always the distance from your vertex to your focus. And then we can put that in for my c in 1/4c. So this one's slightly different. They actually gave me the vertex, but I need to still find my stretch and everything, okay? So you want to be careful and make sure you pay attention to what's what. This is my focus. So I'm going to go to -3, 6. So let me just count -3, 1, 2, 3, 4, 5, 6. That's my focus. My vertex is at -3, -4. So -3, 1, 2, 3, -4. That's my vertex. What direction is this parabola going to open? Well, it's going to open up because it has to open towards my focus. So it's going to open up, and that's why it's really important that you label which one's your focus and which one's your directrix, so you don't think it's opening down because you go to the wrong point by mistake. Okay, it's going to open from here up towards my focus. Again, I'm not being accurate with that stretch. Now, since they gave us this vertex, I actually already knew y is equal to a times x plus 3 squared minus 4. I already knew that. But I needed to find my a. And my a, remember, is equal to 1 over 4c. What is my c in this problem? So my c is 10, which means my a is going to be 1 over 4 times 10, or that's a 0. Or 1 over 40. That is my a. My stretch is 1/40. And you see these are further away and it's wider. Okay. So my equation is going to be y equal 1 over 40 times x plus 3 squared minus 4. And that's our equation. Okay. So on this one, we can identify the vertex because it's in the nice form. So the vertex is going to be 4, 1. So I'm going to go plot that 4, 1. And that is going to be my vertex. Okay, that is my vertex. I know this parabola opens up. I'm not going to be accurate with the graph of it right now. I know it opens up. Why do I know it opens up? Because of the positive 3 in front. Okay, positive 3, it opens up. Now, our axis of symmetry. Our axis of symmetry is the line that if I was to draw it like this, cuts it in half. That's what our axis of symmetry is, that line. It is a line, it is not a point. So this line is x equal 4. It has to always go through the x coordinate of your vertex for these parabolas. Okay? That is not my directrix. Okay, my directrix will never go through my graph. Okay, that's my axis of symmetry, cuts it in half. Now, my focus is going to be a point that's going to be somewhere on this axis of symmetry, but up here inside, not down here. Okay, up here somewhere on this line is going to be my focus. Beneath at the same distance, I'm going to have my my horizontal line. That's going to be my directrix. Now, my focus is always C away from my vertex. I don't know what C is, but I know what A is. I know that my A is 3. And I know that A is equal to 1 over 4C. So I can take 1 over 4C and set it equal to 3 and solve. I'm going to put the 3 over 1 and cross multiply and get 2C equals 1. So C is going to be 1/12. Now, this is why I like to graph it so I understand where I am. Remember, C is the distance from your vertex to your focus. I'm going to zoom in for a sec. So here's my vertex. My focus has to be on this line inside the parabola. It is 1/12 above that vertex. What would the coordinates be? So since this C is 1/12, and I'm going 1/12 above this point being, let me just jot it down here. That point was 4, 1. That means that this point here is going to be 4, 1 and 1/12. So this is going to be 4, 1 and 1/12. That's my focus. It's 1/12 above my vertex. Now that's 1/12 above my vertex. 1/12 below, okay, I'm going to zoom in for a second. 1/12 below that, let me maybe make it thinner. 1/12 below that is going to be my directrix. What would the equation of that be? So this is going to be y equal, and the vertex was up at 1. I'm 1/12 below, so I'm at 11/12. So this is going to be y equal 11/12, and that's my equation. Now, the next one, I'm going to talk about something that I wrote on this paper, but we haven't discussed, okay? So again, I'm just going to the blank part of our notes, and I'm just going to jot down the following information for our next problem. If I have y equal ax squared plus bx plus c, which is in standard form, it's not the nice vertex form, and I have to find my vertex, I could complete the square, I could find my x-intercepts and average them. I could do either one. So what I'm going to do is I'm going to find my x-intercepts and I'm going to average them. So to find my x-intercepts, I would put 0 in for my y. And I would solve this. I would solve this to find my x-intercepts. Can anyone tell me what are the x-intercepts for this equation? So if I want to solve this problem, I can solve it using the quadratic formula, right? If I want to find x for ax squared plus bx plus c equals 0, I can use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. Those are my two x-intercepts for that equation that I just wrote, for that parabola, that general parabola up there in standard form. Well, so these are my x-intercepts. So to find my vertex, I average my x-intercepts. I add them up and divide by 2. So I'm going to take my two x-intercepts, one of them being negative b plus the square root of b squared minus 4ac all over 2a. The other one being negative b minus the square root of b squared minus 4ac all over 2a. That's me adding up my two x-intercepts. So to average them, I add them up and then I divide by 2 because I'm averaging x-intercepts. Okay, and I get that. Now that doesn't look very nice. Okay, doesn't look very nice, but I believe on the top, since they're both over 2a, I really could write negative b plus the square root of b squared minus 4ac plus negative b minus the square root of b squared minus 4ac all over 2a would be me adding them together because they both have a common denominator, so I can combine those fractions together. Now, I still need to divide that by 2 because what I just wrote in black is me just adding my two x-intercepts, the teal one and the blue one together. That's what gave me the black. But I think we can clean up the top a little bit. Can anyone clean up the top at all for me and tell me what everything in black is going to be? So on top, I can clean this up. Sorry, I keep on hitting the wrong button. I can clean this up because I have a positive square root and a negative square root, which are going to cancel out. And so I am on top going to end up getting negative 2b over 2a, and it is still being divided by 2. Okay. Now, let me just focus on the black. Do we agree that the negative 2b over 2a is really just a negative b over a? Do we agree with that? And then that is still being divided by 2. So all I did was I just canceled out from the top fraction, the 2 on top and the 2 on bottom of the black fraction. Now, when I am dividing negative b over a by 2, it's the same as multiplying by the reciprocal. Okay, when I divide by a 2, it's really like multiplying by its reciprocal. And I end up getting negative b over 2a. That's what I end up getting. That negative b over 2a, which is the average of my 2 x-intercepts, is the x-coordinate of my vertex. So up to this point, I have been having us use completing the square to get it into the nice graphing form. There is a formula for the x-coordinate of your vertex. It is negative b over 2a. That's what it is. We still need to know how to complete the square, especially when we're dealing with circles, because we don't have a nice little formula like that for our centers, okay? Now, do I expect us to do this? No, but I want us to understand where this is coming from, and hopefully to help us remember it instead of just trying to half remember something. So, why in the world did I do all that? Because here I wrote, recall that the x-coordinate of a vertex is negative b over 2a. So if I want to answer the same questions we did for example 4, which was in nice graphing form, and this one's not, I don't have to complete the square first. I know that my x-coordinate of my vertex, x-coordinate of vertex is going to be negative b. Well, what's my b? 12. So negative 12 over 2a. What's my a? 3. And this is going to be negative 12 over 6, which is negative 2. That is going to be the x-coordinate of my vertex. How do I find the y-coordinate? Well, to find the y-coordinate, plug it in. Plug it in. Plug it into your equation. We got this equation right here, right? Plug it in. So I'm going to go y is equal to 3 times negative 2 squared plus 12 times negative 2 minus 1. I'm literally plugging it in to see what I get out. Let's move it this way. So when I do that, I'm going to get negative 2 squared is 4. 4 times 3 is 12. Minus 24 minus 1. So I'm going to get a negative 13 when I do that math. Negative 13. That's my vertex. Okay, that's my vertex. So I didn't have to complete the square, which I'm glad of because there's a 3 in front of it. I don't like to do it when I have a lead. Now I could have added my 1 and then factored out my 3 for my 3 and my 12. It was a doable problem, but this is another approach. Okay, so now, are you guys fine with me adjusting my x-axis on my page so that I can get down to a negative 13? Because I don't think I can. So I'm just going to shift it up and pretend that this is my x-axis instead of the other one. You guys fine with me doing that? So that's going to be my new x-axis. Okay. So I'm going to go to -2, comma, -13. So -2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. So this is my -2, comma, -13. Having my x-axis be up. I moved it. I shifted it. Okay. Now, does this parabola open up or down? Well, I hope it opens up because I don't have much room to go, but it is going to open up because my stretch is 3. It's a +3. So this is going to open up. Okay. And again, I'm not being accurate with the stretch, but it's going to open up. Again, I like to see a graph to help me find all these pieces so I know exactly which corner is being affected. So my axis of symmetry. My axis of symmetry is going to be the vertical line that goes, whoops, help if I could draw. The vertical line right here that goes through that vertex. And that's going to be x equal -2. That is going to be my axis of symmetry. Okay. Now on that axis of symmetry, somewhere on this axis up here, inside my parabola is going to be my focus. Somewhere on that orange line, inside my parabola is going to be my focus. Now, I know it's going to be C away from my vertex, but I don't know what C is. I do know what A is. I know my A is 3 from the problem. And I know that A is equal to 1/4C. So I can solve for my C. So I'm going to go 3 is equal to 1/4C. I'm going to cross multiply. I get 12C is equal to 1. So C is 1/12. So if my C is 1/12, that means I'm going to be going up 1/12 and down 1/12. So I'm going to be going up 1/12 above, 1/12 above, and I'm going to be going 1/12 below. So I need to know how to find the focus and the directrix. So if my vertex is at -2, -13, and I'm going to go 1/12 right above it, I'm going to be at -2, comma, -12 and 11/12. Does that make sense? Because I'm 1/12 above. And then my directrix is going to be 1/12 below. So that's going to be y is equal to -13 and 1/12. And those are my answers.